Structure project presentation. What is queue? Queue is an abstract data structure that is similar to stack. Queue is open at both ends. One end is usually used to insert data, the other end is used to remove data. Queue operates on the basis of first in first out principle, or first come in first out. An example can be made as a customer standing in queue at the grocery store at the payment booth. The person who comes first will be served first. Insertion occurs at the rear of the queue while deletion occurs at the front of the queue. Here we can see an illustration of the queue. What is the difference between stack and queue? The stack and queue, although look similar, but they are different. We can see the differences here. Stacks are based on last in first out principle. The element inserted at the last is the first element to come out, while in the queues are based on the first in first out principle. The element inserted at the first is the first element to come out. Insertion and deletion takes place at one end in the stack, while in queue insertion and deletion takes place on the opposite sides. Insertion takes place at the rear while the deletion takes place on the front. The insert operation in stack is called push, and the insert operation in queue is called enqueue. The delete operation is called pop in stack, and the delete operation in queue is called dequeue. Here is an simulation of queue. Insertion and deletion happens on different ends. ENQUEUE. ENQUEUE, addition of a new element to the queue is called ENQUEUE. Adding a new element will be performed after checking whether the queue is full or not. If the queue is full, no new elements will be added. If the queue is not full, then an element can be added in the queue. If the rear is less than n, which indicates that the array is not full, then store the element array rear and increment by 1. But if the rear equals to n, that is the total number of elements, then it is said that overflow condition and the array is full and enqueue cannot perform. Here we can see the code of the enqueue. At first it checks whether the array is full or not. If it is full, then the queue will perform overflow. If it is not full, then the following actions will be performed. DEQUEUE. DEQUEUE is the removal of an element from a queue. DEQUEUE usually occurs when there is at least one element in the queue. If there is no element in the queue, then DEQUEUE cannot be performed. The rear must be greater than 0. Now the element at the array front can be deleted, but all the remaining elements have to be shifted to the left by one position in order for the dequeue operation to delete the second element from the left one on another dequeue operation. Here is the code snippets for the dequeue. Here we can see that it first checks if the array is empty or not. If it is empty, then queue will underflow, but if it is not empty, then the following operations occur. Here max queue is the highest number of elements that can be stored in the array. Here we can see that in the at the first one in the left, 9 is the element in the front. After enqueuing 4, we can see that the 4 is added on the rear of the queue. Then we dequeue one element, as such the front element is deleted and the 9 is gone. The next step would be 5 will be at the front, then 7, then 3, and then 4. Here is the front code snippet of queue. Here we can see that it first checks whether it is empty or not. If it is empty, the queue will underflow, else the queue returns the front item. Here is the code snippet for isEmpty function. It is a Boolean function which returns true if rear equals to front. Here we can see that the queue is full and no elements can be added here. 21 is the element at the front and 93 is the element at the rear. Here is the isFull function. We can see the makeEmpty functions here. Here we have used the class template. The queue makeEmpty function is of type void. Here the front is made equals to max q minus 1 and the rear is made to max q minus 1 in order to empty the queue. Here we can see the constructors. We have defined the max size of the array is 501. The front we have defined as max q minus 1 and the rear we have defined max q minus 1. The items here we have used the class template. Here is an parameterized constructor. Here we can choose the max we can put the value of the max in the constructor in order to find the max q and front, rear, and items. So far we have been discussing about the standard queue, but there is another queue, that is the double-ended queue. A character is inserted at the back and deleted in the front. However, in a double-ended queue, the characters can be inserted and deleted from both the front and the back of the queue. Here we can see the function of the inserting at the back. Here they have taken an array of q, an integer of elements, integer rear, and integer array size. Here first, if the rear is equals to array size, then it will overflow, else the q rear equals to the element and rear is incremented by 1. There are another type of queue, that is the circular queue. A circular queue is an improvement over the standard queue structure. In a standard queue, when an element is deleted, the vacant space is not utilized. However, in a circular queue, this problem is solved. The vacant places are utilized. While inserting an element, when you reach the end of an array and you need to insert another element, you can insert the elements at the beginning, given the first element has been deleted and the space is vacant. As long as the space is vacant, elements can be inserted at the front. This goes on in a circular motion. Here we can see that 2 is inserted at the front, then 4 is inserted, then 3 is inserted, and the rear is open to insert another element. Then 5 is inserted at the rear. If we want to insert 6 or any number, then that number is to be inserted on the left where there is space, and this is how a circular queue works. Thank you.